Most students in introductory physics find themselves in the following situation. They come across a question they don't know how to do. They stare at it a while, and assuming they don't cheat and look it up on the internet, they go to a professor, TA, tutor, or friend and say, "I don't know where to start." After this video, this will never happen to you again. That does not mean you will never be stuck again. Assuming you're a human, that will still happen. However, you will be able to meaningfully start every problem. And if you get stuck, you'll have a good idea of why you are stuck and what you need to do to get going again. This will go a long way to improve your ability to solve problems and your efficiency in doing so. If you open up any physics textbook, you can come across lots of problem-solving strategies. In fact, there might be problem-solving strategies for kinematics problems and another for force problems, and I developed some specific ones as well. There's nothing wrong with these, but I want you to think about a very general problem-solving strategy. Remember, your goal is not to get really good at solving introductory physics problems. Those problems have already been solved. You want to have a strategy that will take you forward to be able to solve the complex scientific and engineering problems that are in your future. And these categories are the types of things that the most sophisticated problem solvers use, even in complicated research problems. First, to visualize so you understand it the best you can. Brainstorm, where you get all your ideas out on the page. Solve, where you go through the mechanics of solving the problem. And finally, checking to see that your answer is right to the best of your ability. After some preliminaries, I'll look at each one in detail. I want to emphasize the difference in my language between exercises and problems. There are no standard definitions for these two words among books or instructors. However, for our purposes, I want to draw a clear distinction between them. An exercise is a question that if you know the topic, you immediately know how to solve it. For example, a car is traveling at 50 meters per second. How far does it get in 4 seconds? Well, you would know that's 200 meters. Alice has $100, Bob has $50, Carlos has $450. What is the average amount of money the three people have? If you know how to calculate an average, the average is 200. Finally, what is the isospin of a delta baryon? That is 3/2. You may not know what the isospin of a delta baryon is, or any way of going about finding it, but it's still an exercise in the context that you either know it or you don't. And if you know it, you can easily calculate what the answer is. A problem, on the other hand, is a question that, even if you know and understand the topic, you cannot immediately see how to solve it. How do you know if you have a problem and not an exercise? It's pretty easy. It is when you understand what the problem is saying, but you cannot immediately see how to solve it. It's where you have a blank piece of paper and you feel those words coming on, "I don't know where to start." Before we go on, let me emphasize that to solve problems, you need a lot of blank scratch paper. You need lots of space to draw, sketch, write, list, everything. Students think I'm kidding here, but this is no joke. Time and time again, I have students come to me where they're struggling, and 90% of the problem is that they don't have enough space to work. They're trying to work the problems in the margin of the homework assignment, or trying to work a problem straight through the first time on the page they intend to hand in as their final solution. Never do that. Work your solutions on blank scratch paper, then copy over if necessary. Your blank scratch paper is your friend and will help you solve your problems faster. Come to think of it, I cannot imagine accomplishing anything significant without a large stack of blank scratch paper. Let's take a look at our problem. A 400-kilogram velociraptor is 400 meters away from an old and fat physics professor. The raptor is running towards him at 25 meters per second. The 100-kilogram physics professor is running away at an adrenaline-fueled speed of 7 meters per second. Where and when does the raptor catch him? You may or may not find this particular problem challenging. The main purpose is to practice the strategy. Also note that the problem isn't completely defined. When and where compared to what? Yeah, real problems are like that. When a problem isn't completely defined, you don't get to just quit. You get to define the terms precisely yourself. Also, there is quantitative information irrelevant to the problem, the masses of the objects in this case. Also, just like real life, what fun.